Okay, so yes, we were discussing very important new chapter which is gases, and we were done till the basic introduction. In last video we just saw what exactly law of gases means. So I've just written, let me give you a little overview. If you've not watched the last video, but still I would suggest you to go and watch that first. So let's get started. This law tells the relation between what the pressure. If these are the body, here the particles are loosely attached or very far from each other. When we provide them pressure, they will become compressed. When they become compressed, this means we can say they get changed if we increase or decrease the quantity or these all. Second was temperature. This was the heat I have given to solid particles. These are solid, these are the gas. So solid particle are very tightly, and in this, if you provide them heat, they will easily within few minutes their particle will be far from each other as they are. But in solid, you are supposed to give them as much as heat you can to get the temperature. Volume also affects if it's the body, and if I provide a higher volume to one body and lower to another, so volume also affect. Then there's a number of gas molecules, so number of moles of gas that also get affected, because in this, if you have given three, if you've given many like more than 1,000, and in this you're only giving three, so this will also affect. So law of gases simply mean this, which we also done in the last video, but I just given a little overview. So law of gases are many types. The one which we will be going with all, but the first one is Boyle's law. Second is Charles law, not Hall's, but the Charles law. Then we have Dalton law of partial pressure. Dalton law of partial pressure. Then we have Avogadro's number. Then we have last one, which is Gram's law of diffusion and fusion. Law of diffusion and diffusion. Okay, so these all are the main component or the main key of this entire chapter, and I'm sure you can get these all very easily. So in the coming video I'll discuss Boyle's law, because we don't have really much more time to discuss here, but let me just give you a little overview of all which I've just written. So if I just talk about Boyle's law, in this we are supposed to give temperature and number of moles should be constant. Constant means there's no change, there must be no change in Boyle's law because of the temperature and number of moles of the gas which we provide. Okay, that's about the Boyle's law. So here I'm just writing the first one. Law will tell you about what that would be. I'm just writing here just so uh, V V is the volume which should be directly proportional to what? Directly proportional to the pressure. The first law would be this. Then in this, what you need to keep constant, that would be temperature and number of moles. So that should be crystal clear, but we'll discuss every single point of this. Okay. Then if you talk about the Charles law, in this you need to volume should be directly proportional to pressure. So this means if the one will increase, second will also increase, but in this condition would be different. And here you need to put for constant P, which is pressure, and N, which is number of moles. These all should be constant. Okay, and if we talk about the third, not third, but the Avogadro's, because these both are the third and fifth are the conditions, but these all are the law. Avogadro's number, not Avogadro's law. So Avogadro's law, in this you should have directly proportional relation with the number of moles of the gas, and something should be constant would be pressure and temperature. So we can say these all should be constant. So these all are the law which we'll discuss, and these Dalton and Gram law are also